Hello, my name is George Wu, and I'm here today with Group 2. We are presenting Saving Lives by 3D Printing Organs and Prosthetic Limbs. Here's the agenda for our presentation today. And now Chrissy's going to talk to you about 3D printing scope.
3D printing or additive manufacturing is a process for making a physical object from a three-dimensional digital model, typically by laying down many successive layers of material such as thin layers of live cells, plastic, or metal. The worldwide 3D printing industry revenue is expected to exceed $21 billion by 2020. 3D printing has been advantageous for the medical industry, aerospace and aviation industries, automotive industry, industrial printing, and architecture. It is used for prototyping, designing, and modeling structures and end products. 3D printing reduces time to market, leading to decreased production expenses. Medical science is exploiting this technology at an extremely rapid rate, allowing patients to benefit from 3D printed implants, organs, and prosthetics. Next slide. 3D bioprinting of human tissue has been around since the 1990s, but of late the development and implementation of this technology in medical sciences has allowed scientists to shift from printing tiny sheets of tissue to entire 3D organs. Layers of living cells are deposited onto a gel medium and slowly built up to form a three-dimensional structure by using inkjet techniques. From 2018 to 2023, the 3D printing medical devices market is expected to grow at a compound annual growth rate of approximately 18%. Market growth is fueled by research and development investment, the increasing scope of application, and rapidly expanding customer base. Factors that may slow growth are unfavorable reimbursement policies, the high cost of printers, biocompatibility issues of 3D printed medical devices, and limited technical expertise in medical devices. Now, Diana is going to talk to you about stakeholder analysis.
The key stakeholder in this industry are, one is the FDA. They have a high influence and high importance. They're key in the regulatory aspects, and they are important in that without getting the companies need to get their approval in order to get their product to market. Consumers play a major role also in that they are the ones that use the devices. Hospital administrators, they have an important role. However, they don't have very much influence in the market. Venture capitalists have a lot of importance in that they provide financing, but they have very little influence in terms of regulatory or moving the product in any directions. Scientific organizations and associations, they haven't really come up to their own. They haven't set their benchmark in the industry. Supply chain have low influence and low importance. When it comes to federal government and organ donation agencies, they have little influence at this point and little importance. Inventors, on the other hand, have a great influence in that they are the ones that are driving the innovations. But when it comes to importance, they have very little importance in this area. And now we'll hear from Monica.
When we look at the sizing of the market for 3D printing of organs and prosthetics, we found that with regards to organs, there are over 600,000 people available in this category that's in need globally. We know that this market could grow to the size of $13 billion as a maximum. When we looked at prosthetic limbs, we know that there's available population size for the market of 31 million people globally, and the maximum market could be $39 billion potentially. We also compare this back to General Electric, who sells 3D printers. We know that they're selling them for $1 million a piece. As we double click on both of these categories, we found that with regards to organs, we researched and realized that the cost per printed organ ranges between $10,000 and $20,000 a piece. We estimated that each printer could potentially print 50 organs. We also, which translates out to $1 million, which is in line with GE's numbers. We also found that from a Gartner report that 35% of all implants and surgeries as of 2019 will be using 3D printed organs. As we double click on the prosthetic area, we have found through research that $1,250 is going to be the average price of prosthetic limbs, down from $10,000 to $50,000. We also found that in this market space, 35% of the population by 2019 will also be using prosthetic limbs that are 3D printed. I will now transition over to George, who will talk about market segmentation.
Thanks, Monica. So when you're looking at the market segmentation, in terms of organ and prosthetic applications, they actually occupy a broader segment of the overall market for 3D printing manufacturing within the United States. As a matter of fact, applications for healthcare purposes actually constitute 19% of the industry revenue growth overall in 2018. And when you're looking at the different segments, there's types, technology, and end users. Taking you to through the different types of 3D printing applications, there are flat structures, which include skin. And French cosmetics company L'Oreal actually partnered with the US biotech company Organova to research printed skin tissues. They wanted to test cosmetics on these artificial skins. In terms of tubular structures, these include blood vessels. Chinese researchers at Sichuan Revotech were able to successfully print and graft blood vessels in rhesus monkeys in 2017. What was interesting was that there were no rejections from an immunology standpoint. Next is hollow structures. This is a picture of a human bladder that was seeded with human cells into the 3D product at Wake Forest Institute of Regenerative Medicine. Researchers actually implanted this organ into a 10-year-old boy with spina bifida. In terms of solid structures, these 3D printed organs include livers, kidneys, and pancreas. When you're segmenting the medical device market for 3D printing applications, you can also divide it into different types of technology and end users. Next, I'll turn it over to Allah to discuss non-market forces at play.
From a policy standpoint, the FDA has a regulatory classification for devices made using 3D printing technology. In a broader aspect, there are pre- and post-market requirements. Specifically to the industry, they issued a draft in 2016 for the purpose of advising manufacturers producing devices through 3D techniques. This draft guidance is organized into two areas. The first is design and manufacturing considerations that provides quality system requirements for a device. The second is device testing considerations, which describes the information provided in pre-market submissions, pre-market approval applications, humanitarian device and investigation device exemption applications for a 3D printed device. Development of 3D printed prosthetic sockets. All major lower limb prostheses are comprised of the socket, leg, and foot. Due to the forces generated while walking, the socket is considered the most important of the three. If it's uncomfortable, the patient won't wear it. Sockets are unique to each individual, and traditionally, the manual process involves using plaster of Paris to capture the shape of the residual limb. Rapid prototyping, or RP, creates physical models directly from 3D computer data. It's known to be a quick and cost-effective way of making non-functional prototypes. Research, however, shows that the production of prosthetic sockets directly from 3D computer-aided design data using RP technology is possible. They are comparable in comfort, strength, and performance to those made by traditional computer-aided design techniques. Next slide. A notable market trend is the emergence of a new technique of 3D bioprinting of tissues, vasculature, bone, and potentially organs. It utilizes 3D printing to create patient-specific tissues for the development of specific and personalized treatments. This breakthrough is expected to become a part of mainstream medicine within the next 20 years. Research in this field is still ongoing in both university and private settings, as the human body is very complex and replicating its exact functions is challenging. With that, we conclude our presentation. Thank you.